comment, subscribe.
I'm going to make some small minor changes to the TT. Since we have the Motion Raceworks billet fill sensor mount, what I'm going to do is change a few sensors and move them around into different locations. I'm going to take the original factory low fill pressure sensor and move that to right here. Reasoning for that is because our flex fill sensor actually measures field temperature also, which is a great thing. So that knocks out two birds with one stone, being able to measure the fill content as well as the fill temperature. Therefore, there's no need for this sensor right here. We'll take the low pressure sensor, mount it right here, and more likely we'll use this sensor in another location, possibly put it into a coolant jacket. Therefore, we'll be able to monitor our coolant temperature as well as coolant pressure, so that way if we see any type of spikes, we can know that we possibly have a head gasket that's possibly failing or boost creeping into the system. Let's get with it and start making some changes. Also, what I want to do also is prep the engine for breathing some life into this thing. We still have pretty much on the cam sprockets all the factory trigger points, and with our MoTeC, I'm only going to use one of these. I'm going to pop out the spark plugs, we'll take off the valve cover, and we'll rotate this engine around until we get it at top dead center, and we'll line up that with this inlet sensor right here for monitoring the cam position for the intake cam. Once we line all that up, then we'll remove the remaining teeth so that way we don't get any type of false triggers in our MoTeC unit. Let's get these cool on plugs removed. These things snapped in there pretty good. I'm still probably make up some brackets or some mounts for them. Oh yeah, she's on there. Yes. At least we know standard and typical vibration isn't going to cause it to pop off. That would have been my go-to work alarm. We'll get ready for work. So no overtime today, which gives us a little bit of an opportunity to play with the TT, which is good. We're close to being loose. Here we go. Yeah, baby. Okay, let's get these plugs out. Usually I'll take the plugs out first, because I don't want to drop any type of debris down in the cylinder. Inside the cylinder head, with it being open and exposed. This baby holds onto the spark plugs pretty good. Nice little wobble head. And of course the O-ring, sealing ring in there is pretty nice and tight. So that way you don't drop a plug down in the port and bend the head up after you've adjusted the gap. a nice gap set and drop this in there, and you can actually close the gap to close up, which would not be good. And just for a starter, we're running the standard benzo plugs, but we do have some nice plugs that I searched out for using in this type of engine. Took a lot of research, but we'll get an opportunity to test the different heat ranges of these plugs. What I like to do also, spray a little fogging oil in here. Since the engine's been sitting for longer than a minute, that's being a little sarcastic. A little sarcasm there. This engine's been sitting for years. It's been sitting for years, baby. Look at them billet cams. Okay. So what we're gonna do, we're going to rotate this engine around to TDC, and you can see everything is still lubricated up pretty good. I got the assembly lube and the grease on here. Still probably may put a little bit more on it once we go to crank up the engine, just so that way we still have some lubrication until the oil pumps back up. Unfortunately, this is not like a lot of the older style Volkswagens where you can use a primer and get a drill and rotate the shaft and prime the pump up, because our pump is located on the side of here. So we probably come up with a different way of priming the oil and getting it to at least pressurize before just cranking the engine over, rotating dry until you build up oil pressure. That is something that I do not like. Okay, so next step, what I'm going to do is rotate the crankshaft around until we hit TDC, and then we'll go with removing a few of these teeth. And right there, we're pretty much lined up with TDC. The harmonic damper has like a little small U-groove, a slot cut into the damper itself. And on the seal cover, you have a line. When those two are lined up perfectly, you're at TDC. Another way that you can tell if you're at top dead center, cylinder 1, your cam lobes are facing towards each other, meaning they're up. Your intake valves are closed, and that piston is all the way up top at TDC right there. So my piston is all the way up here, making contact with the piston. Right here, this would be number 2, which is dropping all the way down. So that's a couple ways you can tell it TDC. But I'll pull off that damper. You can see the backside of it. So for those that don't know, you can get a better look at where TDC is on that damper itself. And with the damper off, you can see the small little slot that's notched into the damper. I just actually put a paint mark on it, so it's actually a little easier to see. But that little slot is very small. Once you line that up with the cover, top dead center, baby. It's been so long since I've actually had the side cover off. I actually have TDC marked on the pickup itself. I would have thought it would have been one of these smaller ones, just normally you would think as your trigger for your sensor, but it's this large one right here, and I have TDC painted on there. So with something this wide, you definitely have quite a bit of dwell time. Of course, this would be rotating back and forth for adjustment for varying in your intake camshaft, but we have the Schimmel Performance pretty much fixed adjustable sprockets, and I mean fixed by being able to set it to where you want and lock it in itself. Some people have moved to keeping these, but in our application producing, I want to say, some extra power, we want to pretty much get all of this wrapped up first. And then maybe in my application, we may start playing with the variable valve timing of the intake and exhaust. But I also have a set of the Schimmel Performance sprockets also. So we'll have a day and night comparison with upper horsepower numbers and with the fixed setup and with the variable setup, and seeing which way is probably a better way to go for a performance application. In roll racing or something, I would say you definitely, the adjustment will probably be the benefit and be an advantage. But also if you have a turbocharger that you can spool up really quick, that pretty much takes all of this out of the equations for the most part. There's a major benefit because it's already been tried and tested that engines make extra horsepower with variable valve timing. So that's been a proven fact right there. But depending on where we're going to be at in the RPM band as far as racing, that's the deciding factor for the most part. So let's go ahead and take this cover off. We'll pop these out, or I'll even use the original one, and we'll shave off these extra teeth that we don't need and put it all back together. It would have been nice if I had did that when all of this was off, and then I don't have to go back and torque all of this stuff back down to spec and everything. But let's do it. I have mostly all the bolts removed off of my side cover from all the way around the perimeter, except for the last bolt. I'm in the process of taking this top bolt out right back there. What I wanted to do when I was installing all the parts and fabricating everything into position, I wanted to make sure that we could still gain access to the sprockets without having to remove a lot of turbo piping or anything, and it'd be a little easier accessible as far as making adjustments to our sprockets while we're still in the research and development phase, and until we can figure out what's the sweet spot that this engine likes with the type of camshafts that we have. Well, the drums are rolling. Let's see how difficult it is to get this cover out of position. I'm going to have to go back in here with some sealant to reseal this cover. And we're looking good for the most part. We're sliding out of position. My turbo piping is cleared. Sweet, baby. Yes, indeedy. So we have full access to the side of this. If I wanted to take this whole boat out completely, swap out anything, we have that clearance that we need. That's great. And right on the side of the sprocket, you can see where I still had TDC painted on here from when I was actually assembling the engine and double checking and making sure for confirmation I had everything there. So pretty much the real reason why I didn't remove these extra teeth is because at one point I was going to start this engine up on the factory ECU, and then time started getting away from us, definitely, and it's setting everything up, trying to configure the engine to run off of the factory ECU, and then switch back again and go to the MoTeC. I just said, forget it. Let's just go straight for the MoTeC. That way it'll reduce the downtime instead of doing everything twice, because in reality, we're going to get our performance gains from the MoTeC for the most part, not necessarily the factory ECU. You can only push the factory ECU, but so far the MoTeC is where it's at, and that's what I decided to just go straight for that. This intake trigger pickup is pretty much held in position by the bolt itself, which is keeping it compressed in, and it has dowel pins that have it seated inside to keep it lined up with the adjustable sprocket. What I did was, as you can see a small gap right there. I used my screwdriver. I used two of them on each end and went against the bolt and used it as leverage just to pry these out. So that way, I'm going to try to attempt to keep this in a position, and I didn't want to have to do any type of banging or anything and have the sprocket drop down. It may fall down anyway, even though it's held in position by a dowel pin, but you can see right here, this one's tightly up against it, and I started pressing this out. I'm going to continue to loosen up the bolt and pry this until we can get this trigger pickup off. Okay, you can see the dowel pins down inside there. So this is actually loose now. And once I get it off, you'll be able to get a better look. But now we have this off. Next step, let's go ahead and thread this bolt and see if we can get it out without this sprocket dropping down. I have the ARP bolt removed, and I installed the factory bolt back in position. stuck this in place just to keep this sprocket assembly from falling off. You can see a better look at the dowel pins right here that's used to hold the back of these in place. It's just usually only 2 of them, but primarily the bolt keeps this compressed in, and the dowel pin keeps these centered from spinning off of the original mounting surface. The back of these, as you can see, just 1 dowel pin to keep this fixed in alignment with your camshaft, but it could still potentially fall off here, and that's why I wanted to kind of put a bolt in here to keep this from dropping out of position. Let's go ahead and shave these teeth off of here, get it back down just to the 1 TDC tooth, and put it back in position. We'll put some ARP lubricant on here and thread it in. I shaved off 3 teeth off my trigger wheel and deburred all the sharp edges off. So we're pretty much good to go for putting this back in position. What I'm going to do is reinstall the ARP stud. This time I'm going to use a little blue Loctite on there. Originally I had the ARP lubricant and it held very well, but just for my own safety and security and peace of mind, I want to put a little bit of thread sealant on the threads, and I'll use the ARP lubricant under the head of the bolt and around the washer and reinstall that back in position. The exhaust cam, I'm going to leave these teeth on here for the time being because there's a few things I want to test out with the exhaust cam and using the MoTeC to monitor the position of that, and a few tuning tricks that I want to try out. But for the time being, I guarantee you I'll be back in here playing with this in the future. But until I decide which ones are the most critical ones, we'll leave this be for the time being. Let's put this back in position, torque it down to spec, and start putting everything back in position. So basically what I was doing is setting this up pretty much to match my simulator. What we had on my test bench, I had utilized a electromotive crank / cam trigger simulator, and I used that to run the MoTeC to simulate just as if my engine was running. And all I'm doing is going from the test bench to configuring and setting up the car in the mechanical aspect so that the computer can see the same thing in detail. Off the crankshaft, the 60 - 2, and then here will be our cam sync. ARP bolt, not stud. My machinist would hate every time I say stud. He's technically right. ARP bolt. I know what I mean. I know the difference between a stud and a bolt, but just in case my machinist watched this video, ARP bolt. I'm not going to do a retake just to say stud or bolt or whatever. ARP bolt back in position. I had my bolt put back in position, torqued down to the spec that I wanted to. Kept my camshaft fixed while I torqued this down. Don't want to really give any specific torque specs because these bolts are rated to up to like 98 foot-pounds of torque, and I did not torque them up that high. These are billet camshafts. Can they handle it? Yes, but I didn't want to take a chance of over torquing or stressing any type of components. Next step, one of the biggest things I wanted to, and the reason I said because that stung, I'll just go into it. ARP studs right here. We've had our run-in where I've over torqued a stud and torqued it according to spec, and the cylinder head could not handle it, and it crushed the cylinder head, which set us back a whole nother level. So that's a touchy and sore topic right there. That's why I did the pause. My brain went there, but I didn't want to verbally speak it. But anyway, that's that. But back down to the nitty gritty. One of the primary reasons why I wanted to get in here also, other than shaving these off and pretty much getting this engine set up for the MoTeC being able to read the cam sync position as well as the crankshaft. That's pretty simple as far as the crankshaft. This is simple as far as getting the cam sync set up. The nitty gritty is I wanted to see and check out the position of my cam lobe for my direct injection pump right there. So as we can see, my engine is pretty much close to top dead center. That's the little slot right here when you put the fixture tool in an old back in the day video. I may have did a video shoot of where I utilized the tool, and it's two different ones to lock this in position when we was installing the timing chain, and you had to keep this fixed in position. But anyway, I wanted to monitor the position of this, and that will help me with the tunability of the MoTeC. I purchased this sensor right here, and I want to position this sensor and see it measures up awesome right there. I wanted something that would pick up the cam lobe right here without, of course, making contact to here. Have it elevated just a little bit, but we want to pick up our cam lobe. This little sensor right here can measure, the switching frequency is 3 kilohertz, and that is somewhere roughly in rotational RPM. It would be pretty much equivalent to around 180,000 RPM. This would pretty much suffice for me monitoring this. And what I would like to do is utilize this to help me tune the direct injection, and that way I'll know where this cam lobe is throughout the whole RPM band, and we can adjust the frequency of our relief valve, which is on the front down here at the bottom. Let's see if we can shine a little light down here. And right here, that is our relief valve. And relief valve, spill valve, regulator, same thing. That's mounted on this Hitachi pump right here. That is going to control, that is the bread and butter of making sure that this system is functioning properly. And without doing that, it's chaos. You can be fighting the injectors if it's not pulsing correctly, a whole nother can of worms. And that's where it gets very, very technical. But being able to monitor when this is on and off, that'll help me with the tunability of the MoTeC, and totally awesome. So, and of course we can probably just basically go off of timing, whereas every time we hit top dead center is off, and when it rotates around it's back on. We can go off of timing, but I would rather have something a lot more concrete with being able to tell me where we're at throughout the RPM band. And bingo, if we just had to use timing, that's fine. If we can get this to work, that's even better. And that way we'll have some extra data and input for our MoTeC unit. To get this to work, I have to drill into this cover right here. So that's pretty simple, no big deal. And as we can see, I would have to be just a little bit above here, coming right above this base right here. This little circle here is actually this shaft right here for this. All I would have to do is just come up a little bit, but what I want to do, you can see the metal is thicker right here. And I want to weld the block on the outside. I can put a small block on the inside also, but I'd rather weld something on the outside of this cover and then thread into it, drill, tap, thread into it. Before I go through the process of resealing this up and putting it back in on a semi, not permanent, but bolting it up until we have to come back in here again, I want to go ahead and really get this set up if possible. Therefore, what I'm going to do is loosely just put this back on in place, thread my nuts and bolts in. I'll just tap the cover back on with the dowel pins, just make sure everything's lined up, tap it back on, loosely run a few bolts in just to keep it sealed up from moisture or anything getting in here, even though the car's in the garage. But that's what I want to primarily do until I can modify this cover, the side cover, and thread and tap and get this into the right position. Will this give us some good tuning information? If it works out, I want to say yes, but it's all experimental, and that's what this whole project is a build experiment, a build project, and let's see if we can get as much power out of this cast factory block, forged block, cast iron block, but modified with forged crankshaft. We have some nice strong rods, and we got the strong JE pistons. Stage 1, let me say that, just to clarify that to be specific. Our stage 2 and stage 3 pistons are on a whole nother level. But if all of this works out as planned, this engine should make some pretty good horsepower with this setup. All to be determined. We'll see. Actions speak louder than words, and I'm not a person that just likes to talk a lot, even though I'm talking my ass off. But I don't want to just continue to talk. I'm a person that believes actions speak louder than words, and the only way to know this is put the money where it counts. And let's see if we can get this bad boy putting out some horsepower numbers. And I honestly, truly think it will. Truly think it will. But to be determined, and we'll see. Pretty much accomplished somewhat of what I wanted to do today. Shaved off the teeth on the intake cam sprocket so that way we can prep this engine for actual startup and get rid of the simulator and be able to put the MoTeC on this unit and get this set up. The two main things I needed to do in order to start the ball rolling in that process, which was shave off those so that the engine, the MoTeC, can know where my cam sync is, and the crank trigger, that's already good to go, 60 to 2-1, and primarily to view and confirm the location of my direct injection pump cam lobe. And we have the sensor. I took the cover off and put a older temporary cover on just to keep everything covered up, as I stated before, keep it away from any type of moisture or all the freaking spiders that roams around in my garage, so the engine doesn't get infested with spiders itself. But either way, I have this off so that way we can prep to modify it, weld the block on the outside, and see if we can configure this sensor to monitor our cam position for our direct injection pump. That will help me out tremendously, and with determining, I'm saying frequency, but the duty cycle, we can match the duty cycle with the position of the cam lobe. I can blend and bleed off the valve with consistent duty cycle per cam lobe position and RPM for getting the good, somewhat accurate fuel rail pressure for our direct injection pump. It's a lot. Most people delete these, but if you can make it work along with your port fill injection, it's a major advantage. It has its limitations, and of course, now you're seeing a lot of aftermarket people wishing we could get a lot more power out of the direct injection itself, because the horsepower gains are tremendous. Even just spraying fuel into your intake ports, your fuel displaces a lot of the air. Direct injection pump, you're getting the full flow, airflow capacity of your cylinder head and not being blocked off by fuel. And of course, we're going to need that additional fuel for our stage injections to get the horsepower goals that we want to achieve, because there's no direct injectors on the market that can flow what we would like to see. A lot of performance cars running DI injectors are going through the same thing. But until that market expands, where a lot of companies jump on the bandwagon and have some high flowing direct injectors, hey, but we're still limited to a certain extent, because you only can pulse these injectors on a certain revolution. If you pulse them too soon, you can blow out your spark, and it's all in having accurate and critical timing. That's why I wanted to set this up also, so that I can get this thing timed excellent and flowing good, so that way my direct injector system is not in question. It's flowing good the way I want, and then I can play with all the tricks and everything that you can do with DI, as well as the icing on the cake, which would be our port injection for big horsepower numbers, spraying as much fuel and getting it into this engine as possible. But port, that's easy. This is where things get complicated with this direct rails sitting here above and below. So we have 3 fill rails, but I need to make sure I get these 2 most important ones working fine. That's to get the car running. That's your idle. That's everything. This is just kicking in for high horsepower and startup and other little things that I'll use just to make sure we don't have any carbon buildup on the back of our valves. But these are really pretty much fully threshold kick in when we're trying to push some numbers.